Alright guys, so this is the second part of notes for January 10th. And we're going to be talking about the discriminant. And we're still dealing with the quadratic formula. So if you recall, the quadratic formula is negative b plus or minus square root b squared minus 4ac all over 2a. So here's the entire formula. The discriminant, what it's talking about is what's underneath the radical. So just this portion, the b squared minus 4ac. Okay? So I'm going to write that over here. B squared minus 4ac. That is the formula for just the discriminant. So for each one of these, what we're going to do is find the value of the discriminant by plugging in our b, a, and c. We're going to describe the number and types of roots by using this table. And then we're going to find the exact solutions by actually using the quadratic formula. So if the discriminant, so if we calculate b squared minus 4ac, and it's positive and it's a perfect square, so for example like the number 16, then our solutions are going to be two real rational roots. Okay? If it's positive but it's not a perfect square, like the number 8 or 17, we're going to have two real irrational roots, meaning that our answers will have some type of square root in it. If it equals 0, that means we'll only have one real rational root. And if the square root or the discriminant is negative, that means we'll have a negative underneath the square root in the formula, which will give us two complex roots, meaning that there'll be an I somewhere in our final answer. So let's start out with part A, finding the discriminant. So first thing we have to do is label our A, B, and C. Our A is negative 5, number in front of x squared. Our B is 4, and our C in this one is 1. And notice it's already in standard form, so we don't have to subtract any numbers or anything like that. So let's set up the formula for the discriminant. B squared in this case would be 16 minus 4 times A, which is negative 5, times C, which is 1. So our discriminant is going to be 16, and a negative 4 times negative 5 would be a positive 20, times 1 would be a plus 20. So 16 plus 20 is going to give us 36. So the number 36 is a positive perfect square. So our two types of roots are going to be, this is part B, two real rational roots. Alright, so we've done part A, finding the discriminant 36. We've described their roots using our table over here. And then now we have to find the exact solutions by using the quadratic formula. So the quadratic formula is up here. So the only thing we need to fill in is this negative b plus or minus and the 2a, because we've already found the discriminant. So negative b, that's going to be negative 4 plus or minus square root of, we have 36 over 2 times a, so 2 times negative 5, that's going to be negative 10. And now we just set up our two cases. So the first case we'll have x equals negative 4 plus 6 over negative 10. Then we'll have x equals negative 4 minus 6 over negative 10. So right here, negative 4 plus 6, that's going to give us a positive 2 over negative 10 is going to give us negative 1 over 5. I went ahead and simplified. Alright, over here, negative 4 minus 6 is going to give us negative 10. Over negative 10 is going to give us a positive 1. Okay, so moving on right here, let's go ahead and find the value of the discriminant. And again, the discriminant is going to be b squared minus 4ac. So our b in this case is 22, so we'll have 22 squared minus 4 times a, which is 1, times c, which is 121. Alright, so